Hello, algebra students. Mr. Lawrence here with your flipped lesson for today. And today's lesson is on slope, and I got to warn you, this is one of the most important concepts of the first semester. We will be using slope in everything we do, and it has applications in the real world. You know how a lot of you, like Adam Bliznick, like to go, when am I ever going to use this? Well, I can tell you, you can use slope in many, many scenarios. Today you may not really realize why, but over the next week or two, you're going to start to see that slope has lots and lots of applications. So let's talk about first, what is slope? Well, math teachers like to call slope the rise over the run. And that's a great definition. Another definition, the rise is also known as the change in y over the change in x. Okay? In other words, it's how much a line is changing vertically divided by how much is it changing horizontally. Okay? Um, Now, what is slope actually? Well, it's just a change in elevation. And when you hear the word slope, you think of hills or roller coasters or things like that. But we're going to be doing slope graphically. So it is really easy to do, especially if the picture's already been graphed for you. All you have to know how to do is count. Take this example here. All right, I'm looking at the orange line right now, and I am going to pick 2 points on the orange line, any 2 points I want. Please note that this green point F here is not on the orange line, it's on the blue line, okay? So I am going to count the rise and run from one of the points to another. So I'm going to go from point A to point B, and so I'm going to count my rise. I'm going to go rise 1, 2, 3, 4, and then I'm going to run over 1, 2 to get to point B. So let me see here. My rise for the orange line, the rise number was 4, did we say? And let me double check. 1, 2, 3, 4. And then the run number, this is all for the orange line, the run number was 2. My slope is 4 over 2, or better yet, 2 over 1. Now, normally you'd like to simplify that fraction further and just tell me 2. I'm going to suggest that when we're dealing with slope and we're dealing with lines, you tell me the slope is 2 over 1. Leave it as the simplest possible fraction. Don't go to a whole number on it. Okay? Now I want to show you something really cool here. Let's say you had picked points B and C. Well, I could count up. Let me get a marker here, and see, I'm going to count up from B to C, and I'm going to go 1, 2, 3, 4, and then I'm going to count 1, 2. I got the same fraction, didn't I? What if you had wanted to count from A to C? Well, from A to C, I'm going to go 1, 2, 3, 4, 5, 6, 7, 8. But then when I run, I'm going to go 1, 2, 3, 4. So in this case, I got a slope of 8 over 4. But 8 over 4 simplifies to 2 over 1, doesn't it? So you see the slope, any way you look at it for the orange line, this is the orange line. The slope, any way you look at it, is 2 over 1. Now, try this. What about if I go from C down to B? Well, my rise then, if I go from C to B, I go down 1, 2, 3, 4. So my rise is -4, and then my run is in the negative direction, 1, 2. My run is -2. So in case I get -4 over -2, which simplifies to 2 over 1. The two negatives end up canceling each other out. Any way I look at it, I get 2 over 1. So the slope of the orange line is 2 over 1. All right, let's move on to the blue line now. And again, you can pick any 2 points that you want. If you want to try to pause the video and count it yourself, that's fine. I'm going to go ahead and find the slope from G to I. Normally, I would go the two closest points possible, but I'm going to go ahead and go G to I on this one. Let's see, 1, 2, 3, 4, 5, 6, and then 1, 2, 3, 4. So it looks like my slope for the blue line, oop, not the blues line, the blue line, sorry about that. The slope for the blue line, now of course I forgot what I counted, but I think I went down 6, and then I went right 4. So the slope for the blue line is negative 3 over 2. And it means I go down 3, right 2, down 3, right 2. And if I keep doing down 3, right 2, I always hit the line. Watch this, I'll go from F. I'll go down 1, 2, 3, and then I'll go right 1, 2. I'll go down 1, 2, 3, and I'll go 1, 2. Down 3, 1, 2, 3, and then right 2. And there we go. I always hit the line no matter what. If I go down 3 again, 1, 2, 3, I go over 2. It looks like I'm missing line, but in actuality, that's just human error from my line being set up on the, actually is going through this point here. I apologize for that. But that's why it's so important to be careful when you draw your lines. All right, now, check these out. I'll tell you what, see if you can find the slope of the blue line and then the slope of the green line. If you're still watching at this point, I assume you want to see what the slopes are. I'm going to find any 2 points on the blue line. I will choose this point and this point. I'm going to count my rise, and it looks like I don't rise any. Or in other words, I rise 0. And then I run 1, 2. So I think my slope of the blue line is 0 over 2. Okay, or better yet, 0. And you can leave that as 0 over 2 or 0 over 1 if you like, or you can simplify all the way down to 0. So what kind of line is that? That's a horizontal line. And look at what kind of slope I got. I got a 0 slope. Notice 0 does not mean no. 0 slope would be a perfectly level table. Perfectly level. All right, the green line. Let's check the green line now. And I'm going to use these 2 points here. And in this case, I am going to rise, let's see, 1, 2, 3, 4, and I'm going to run 0. So I get 4 over 0. This should bug you crazy. You should not like this at all. You should have warning signs going off on your head. 4 divided by 0. You cannot ever divide by 0. With a vertical line like this green one, the vertical line, we say that it has no slope. The vertical line has no slope. And that's always true. One way to tell if something has slope, ask yourself, can I ski down it? Let's pretend we had a hill that looked like this. Could you ski down that hill? Sure you could. That has slope. By the way, if you didn't notice, going down to the right means a negative slope. That's right, down to the right is a negative slope. Could I ski down something like this? Okay, that line in effect would be going up to the right. You get my little arrowheads here. And of course we could ski down that, and that would be a positive slope. So this is a negative slope, and this one is a positive slope. Could I ski across something that looks like this? And you're saying, no, but I disagree with you, because I could use my cross-country skis, and here I am cross-country skiing. Wow, now you know why I'm a math teacher and not an art teacher. Wait, I need my poles. And I need my other pole. There we go. All right. I'm cross-country skiing. This would be 0 slope. Okay. Finally, the last question for you is, can you ski on something that looks like this, like a wall? And I know some of you are thinking, why, yes, of course I could. Well, no, you cannot. Because if I put you on the wall, like this, and I turned you, woo, and you were there, the second we let you go, you would fall. And you would fall, and you would land on your head, and it would split open, and your brains would pour out all over the place. And it would be tragic, and I would cry. Anyway, so when we have a vertical line like this, we say no slope. One way to think about it is there's no hope of skiing on it, therefore there's no slope. And that's it. That's slope in a nutshell when you're given a graphed line. I'm going to wrap up the video now because I don't want to get too long. Mr. Lawrence signing off. Good night, everybody.